Good morning, everyone, and welcome to our YouTube live stream of our course. So yesterday we actually just finished our statistics test. So today what we're going to do is we're going to start a brand new topic, which is probability. So I chose this probability unit because it's a short unit, and it's a pretty nice unit to do. And then after this, I'm gonna continue on. Like the next unit would be trigonometry and geometry. So, welcome, and let's get started on our probability unit. So, in this probability unit, what we're gonna do is start off with the introduction. Introduction talks about what probability is and how to calculate some probabilities. So let's take a look at lesson number 1, probability. Um, Probability is part of an area of mathematics called statistics. So we already kind of talked about statistics. So it's just nice connection to this probability unit. Probability refers to the chance that an event will happen. So when we talk about probability, we're actually looking for chance. What is the chance that something will happen? For example, when the weather person states that there's a 30% chance of precipitation, this means that there is a 30% chance that it might rain, but we don't know for sure. If a favorite sports team has 80% chance of winning their next game, it is very likely that they will win. But of course, we don't know for sure if they will win that day. So actually, I this morning I checked the weather station on the internet, and it says today there's 60% chance of snow. So on April 21st, there's a 60% chance of snow. But if you look outside, it doesn't look like it's gonna snow, but there's a bigger chance that it's gonna snow today. So we'll see how that probability works for us. So examine the two statements. So statement number 1. The probability of rain on Monday is 20%. So the probability of rain on Monday is 20%. So the word probability, we can think of it as chance. What is the chance that it's going to rain on Monday? Well, that's 20%. Statement number 2. The probability of rain on Tuesday is 90%. Again, the word probability, we think about it as chance. The chance that it will rain on Tuesday is 90%. Will it rain on Monday? There is a 20% chance, but it's not likely. On Monday, it's not likely to rain, but there's still, we don't know for sure. Will it rain on Tuesday? Um, very likely, but we don't know for sure. Will it rain on both days? Likely, but we don't know for sure. Will it rain on either day, either on Monday or Tuesday? Likely, but we don't know for sure. So this probability is the chance. So it's not 100% chance, and we will talk about the 100% chance later. What does that mean? Uh, so when we talk about probability, it's just a chance that something, in this case, rain, something will happen. So let's take a look at this part here. Probability is often expressed It's often expressed or written as percent. Okay, so when you look on your on your um, on your app and to see if it's gonna rain today, if it's gonna snow, um, those ones we see as percent. So 60% chance today that it will snow on April 21st. That's what I saw at least. But they could also be expressed as a fraction. Yeah, because percent and fraction are very connected. And and if we have a percent and if we have a fraction, we can change that into a decimal. Okay, or we can write it in words. In words. Okay, so um, I just want to let you know at some point during the lesson if there's anything in here that you are not quite sure of or you want me to explain further, please make sure you let me know. Okay. Let's see. So we said here, example one, complete the following table. The first row has been completed for us. So when we see 6/10, so this is written as a fraction. So 6/10 is a fraction. We can write that as a decimal. How do we get from fraction to decimal? So we go 6 divided by 10 will get us this one here. So you can go from fraction to decimal by taking 6 dividing by 10 is going to give us 0.6. Now, on your calculator, if you do this, I'll just show it to you. 6 divided by 10, we get a 0.6. And then you're probably thinking, oh, well, why is this 0.60? Just because we are writing and expressing our number, our answer in two decimal places. So there's nothing after the 6, so we'll just put a 0 there. Okay. So 0.6, or you can write down 0.60. Now, how do we go from decimal to percent? We can go here from decimal. The word percent means per hundred. So we can go 6 divided by 10, we get a 0.6. And to make it percent, we multiply it by 100. So we can multiply it by 100. So it's 0.60 times 100. And then that's where we get a 60%. Okay, so we started off with a fraction, and then we can change a fraction into a decimal. Okay, so this line here means divide. So 6 divide 10 to change it into decimal. And once we have it in decimal, we can go timesing it by 100. And then we can express it in words. So 6 out of 10. So 6 out of 10. So 6 out of 10 chances that it will snow or rain or whatever the, the topic that we're talking about there. Okay, so that's that one. So now what we're going to do is we're going to fill in the rest. And as you can see, some are written as a percent, and then we're going to write it as a fraction, as a decimal, and words. Here, written as words, we're going to figure these out, and then written as a decimal, figure that out, and then this one. Okay, so let's do that. Now, this second line here that we have to fill out, it started off with percent. So 19%. Now we talked about this in class last time. What does the word percent means? It means percent means per hundred. So the word percent means 100. Okay, so 19% means 19 per 100. So we can go from 19% to per 100. We can go from decimal, from percent to decimal, 19. Actually, go over here. We can write it as a fraction first. So 19% means 19 per 100. Okay, so 19% means 19 per 100. And when we do that, once it's in a fraction, we can just divide 19 by 100. So you go here, 19 divided by 100, and you get 0.19. So you go 19 divided by 100 equals 0.19. This one I'm gonna show all of the work in here. Okay, so that's why I had that all written down. And then finally, words. Well, how can we write that in words? So 19 out of 100. Okay, so that one is complete. We started off with a percent. The word percent means per 100. So from there, we were able to write down the fraction. And once we had it on a fraction, we can change it into a decimal. Okay, now let's take a look at this one. This row over here, they gave us the words. So we had to figure out the fraction, the decimal, and the percent. So 35 out of 50. 35 out of 50. So writing it down, we can write it as a fraction. 35 out of 50. So 35 out of, so divided by 50. Okay. So okay, 35 out of 50. Now that it's written as a fraction, we can write it as a decimal. So we go 35. This line means divide. So divide 50 equals, and let's do that on a calculator, see what that looks like. 35 divided by 50 is 0.7. 0.7. Now we can, if we were to express this into two decimal places, so when you do that on your calculator, you only get 0.7, one decimal place. You can add a 0 at the end. And that's it. Okay. So let's take a look at this one. 0.7, and then changing it into percent. So now you go 0.70 times 100. You get 70%. 70%. Okay. If you have any questions, please let me know. Okay, so that one's complete. Now let's take a look at the next one. The next one, we are given the decimal value, the decimal. So how can we change it into either fraction, percent, and in words? Now, because it's a decimal value, the easy way is to write it as a percent. Oops. So you go 0.54 times by 100, and we're going to get here, if we type it in, we're going to get 54%. Now, I know some of you already who are comfortable with this. A way to do percent is to just move the decimal places to the right. This is a shortcut. Move the decimal places to the right 2 units. Okay, so I'll just here, you can move, or you can move the decimal to the right 2 units, 2 places right there. That's a shortcut. Okay, now that we have the percent, we can write it as a fraction. Now that we have a 54%. So 54% means 54 out of 100. Okay, so 54 over 100. Okay, and then now that we have that fraction, we can write it as a words. So 54 out of 100. Okay. So that's that part. We're on the last one. Okay, so this one, we're given a fraction again. So we can go from fraction to decimal to percent and words. So 1 divided by 8. So writing it as a decimal, 1 divided by 8. 1 divided by 8. And then we're going to get a decimal 0.125. Okay. And if the question says rounding it off to 2 decimal places, it would be 0.13. So if you round it off to 2 decimal places, so 2 decimal places is right here, but there's a 5 after the 2, so that will be bumped up to the 3. Okay. Now let's go from here. So from that to percent. Okay. So you go 0.125 times 100. Notice that I'm using the 0.125 instead of 13 because 13 was already rounded off. So I'm just going to use the one that's not rounded off yet to figure out the percent. So timesing it by 100 times by 100, it's 12.5% or 12.5%. Now, if you are comfortable with this, another way of doing that is to move the decimal to the right. And this decimal moved 1, 2, so you get 12. So this is gone now. The decimal is here, so it's going to be 12.5. 12.5. Okay, and then last but not the least is here, writing it as a fraction. Okay, sorry, writing it as words. We can use a fraction to do that. 1 out of 8. 1 out of 8. Okay, so there could be like 1 out of 8 chance of getting picked on something. So writing it as words. So this is a really good exercise to get comfortable with writing fractions to decimals to percent to words and then mix matching it, because when we get into the actual probability part, some word problem, some probability are expressed in words, some probability are expressed as a fraction, as a percent, sometimes as a decimal. So this is a good opportunity for us to take a look at that one. Okay, so if you have any questions, I'm gonna yeah, feel free to ask. Let's get into example number 2. Example number 2. Example number 2 says, in a science textbook, 23 out of 57 pages contain a picture. Express the probability. Okay, so the word probability means, what is a chance? Chance. Express the probability or chance in the form of a fraction, a decimal, and a percent that a randomly selected page. So if we just kind of flip through the page and then we randomly select a page, what is the chance that it will contain a picture? So when we look at this part here, science textbook is 23 out of 57 has a page, has a picture on a page. So this one telling us the probability in words. Okay. So the what are they talking about? What is the probability of something? What is that something? This is what they're talking about. This is the event that they're talking about. Event that is going to happen. Okay, so what are they talking about? The event is the something that they're talking about. So they're talking about the probability. What is the chance of? And then this one here, this is the event, something happening. So writing it as a fraction. So they gave us a probability in words. We can write it as a fraction. We can say 23 out of 57, writing it as 23 out of, so divided by 57. Okay. And then from there, we can write it as a decimal. So how do we do that? I'm just gonna get my calculator. 23 divided by 57 is, now I'm gonna get into a whole bunch of decimal places in here. If we need to round it off, we're gonna round it off to 2 decimal places. So it's gonna be rounded to 2 decimal places, so 0.40. Okay. And then just keep all these decimals right now. And then now we're gonna do the percent. How do we do the percent? Timesing it by 100. So now as you can see, the 2 decimal places for percent would be 40.35%. So as a fraction, no need to round. Decimal, round to 2 decimal places. Okay, so once you have the decimal, keep all the decimal and then multiply it by percent and then round also. Okay, so There you go. Now we're going to get into the next part, which is the word certain event, impossible event, and then complement. So some of these are some vocabularies that we will see in this topic. So certain event, when somebody is quite certain, that means it's for sure, right? So the probability of a certain event, well, what is a certain event? Here's for sure is going to happen. That means the the event will be 100% chance that will happen. So this is the percent way of expressing the probability. Now, if you change that into a percent, into a decimal, you, you take the percent and you divide it by 100 to get the decimal, you're going to get a 1. So for example, if today is Sunday, then the probability that tomorrow will be Monday is 100% or 1, right? So this is written as a percent, and then this is written as a decimal, but because it's just 1, it's just 1. Okay, so certain event probability is 100% or 1. Now the next thing that we're going to talk about is impossible event. So it's like, that's impossible, it's never going to happen. So let's take a look at what that means. So the probability of an impossible event is 0. So that means the chance of an impossible event is 0, either 0% or 0. For example, today is Wednesday, then the probability that tomorrow is Friday is 0%. So that's impossible. If today is Wednesday, tomorrow will never be Friday. So that's what they're saying. That's impossible event. Okay. So certain means absolutely sure it will happen, no doubt about it, it will. Impossible, never gonna happen. So 0. Now, what is the word complement? Complement. Okay, here's another vocabulary that we will see throughout the course, or throughout the lesson and the unit. So a complement refers to the quality of the amount that completes something. So you think of it as the part needed to complete the whole thing. What's the whole thing? So for example, if there's a 20% chance it will rain today, so 20%, that's only a part of 100%. It follows that there's 80% chance that it will not rain. So we say that 80% is a complement of 20%. So the whole thing would be, in terms of the whole thing in percent, would be 100%. The whole thing as a decimal would be 1. And then the whole thing of a fraction will be when the numerator is the same thing as the denominator. Okay, so we'll see it. We'll take a look at the example right away. So the probability says 20%. The whole thing would be 100%. So the complement is 80. So this is the visual part of it. Let's see here. Determine the complement of the following. 15%. So if you have a 15% chance, the complement, to make it the whole thing, would be 100% minus 15%. So 100%. Now you don't have to put percent on your calculator. You can just go 100 minus 15, okay? And you have 85%. So it's nice that we're talking about this now, because we will talk about this in terms of odds and the expected value. Okay. So here, 4/7. So when you think about this, 4/7, what does that mean? It's mean 4 out of the 7 is a complement. So how many are the probability? So I'm just going to take a look at going to draw a picture here. 4/7, that's a fraction. So imagine the whole thing cut into 7 equal parts. So 1, 2, 3, 4, 5. So this, let's say this is the whole thing cut into 7 equal parts. So 1, 2, 3, 4, 5, 6, 7. The complements is 4/7. So I'm going to bring it down a bit so you can see it better. This is the 4/7. It's 4 out of the 7. So this is the complement. And what completes it as a whole? This one would be the other part. So you got 3/7. 3/7. Okay, so that's the explanation for that part. Okay, so that's the visual for that part. Okay, let's take a look at this part. 32 out of 50, or 32 divided by 50. This one here written as a fraction. So 32 out of 50. Now I won't be able to do 50 equal pieces. So that means 50 equal pieces. And if 32 is a probability, then the complement would be, what's the whole thing? The whole thing is 50 out of 50. So this is the whole thing. Minus 32 out of 50. Okay. Now we learned this in grade 11. We said that if we subtract a fraction, we need to have the same denominator. So 50 out of 50, that's the whole thing, minus 32 out of the 50. So 50 minus 32, that's going to give us 18. 18 out of 50. Okay. Then let's take a look at the next one. So the decimal, if it's a decimal, is 0.30. The whole thing would be a 1. 1 minus 0.3 equals to 0.7. Okay. And then the decimal, again, the decimal, the whole thing, part of the decimal would be 1. So 1 minus 0.47 is equal to, if you take 1 minus 0.47, and then you're going to get 0.53. Okay. And then here, now looking at the percent is, the whole thing would be 100%. So if you want to figure this part out, is going to be 100% minus whatever the complement is, 89. And if you type this into your calculator, you don't have to type in the percent. You can just go 100 minus 89 is 11. 11%. Okay. So that's a really nice exercise. Um, I did mention earlier that this is important when we talk about odds and probability, and we're also going to use this topic when we talk about expected value. So something that to look forward to. Let's take a look at the next page. The next page is experimental and in theoretical probability. So what's the difference between experimental and theoretical? So now I brought some props in here. When you think about some kind of a probability, we talk about chances, and then sometimes we talked about dice, right? What's the chance that something is going to show up? Sometimes when we look at probability, we look at the coins, the money, right? What's the chance it will be the tail? What is the chance that it would be the head? So what does that mean? When discussing probability, it is important to know whether we are talking about experimental or theoretical. So what's the difference? Experimental probability refers to probability that is based on past events to predict the future probability. So the experimental, looking at the past event, so um, looking at what's happened before. And then past events can help you extrapolate information about what might happen in the future. For example, weather people use previous weather data to predict what the weather will be like tomorrow, next week, or even next month. So here's the other, let's just talk about theoretical probability first, and then I'll do some kind of an activity here. Theoretical probability. What's theoretical probability? Refers to using possible outcomes to predict probability. This one here, you're using at the possible outcome. This does not need to be any past events or experiments to calculate theoretical probability. So let's take a look at my coin here. So if I ask you, here's my coin, and you probably have seen this before. If I flip the coin, and it lands either the tail, you're probably going to ask, like, what is the chance? What is the chance that it will be landing on the tail? So if you have something that a response, I'll give you a little bit of time to respond. So if I ask you, what is the chance that it will be showing up as a tail? You're probably thinking in your mind, hey, it should be 50% chance that it will land on a tail. 50%, right? And there's also a 50% chance that it would land on the head. Okay, so that's actually theoretical probability. Okay, so let's just do an activity today. I'm just gonna flip the coin. Okay, hopefully I don't. I'm gonna flip the coin 10 times. I'm gonna flip the coin. Okay, and let's see. I'm gonna have head, and I'm gonna do tail. Okay. So because I'm flipping the coin, I'm actually doing here an experiment. Or when we talk about experiment, that's something that we try, right? So this is the other thing that you could help you determine about experimental probability is because it's experimental probability, it's based on the experiment. And what do we do when we're doing experiment? We try things. So I'm gonna try this thing. Whoops. So as you can see, there's a head. No, that's a tail, rather tail. So one tail. Just gonna do a tally up here, and another tail. Okay, tail is winning so far. And then a head, head. Okay, so far they're tied. 2, 2. So I got 4 times. Oops. Head. Okay, head is now 3. So tail, tail. So how many do I have so far? I got 4 tails and 3 heads. So I got 7 7 so far. Head, tail. So right now I got 9. Oops. And then I got a tail. Okay. So in this particular case, this is a very quick experiment. Okay. So this is because I've tried it and I did an experiment on it based on my flip of my coins. All of these are in the past. This is the outcome that I got from the past. So what does that look like? I got 4 heads and then tails, 6 tails. Okay, so that all together, that's the outcome when I flipped the coin 10 times. So because I went through the trial, because I went through the experiment, and all of these information is based on the past events, these are called experimental probability. Now you're probably thinking, well, there should be a 50% chance of getting the head, and there's also a 50% chance that it will get a tail. Well, why did we get that one? Okay, so that's the theoretical probabilities, the 50-50 that you're thinking about. So let's take a look at this example. Amina has 6-sided die cube. Okay, I got a 6-sided die cube here. And each is faced with a different number. 1, 2, 3, 4, 5, 6. Okay, you know the dice. It's 1 through 6. She tosses the cube 8 times. Okay, so pause right here. This is she tosses the cube 8 times and record the result. Because she tosses this, she physically took the dice, this, and tosses it. So this creates an experiment. Okay, so she's doing an experiment. Maybe not creating, doing an experiment. Right? She's doing the trials. She's doing an experiment by tossing it. And how many times did she toss it? She tossed it 8 times. Or she rolled it 8 times. Okay? So she rolled it 8 times. So the first one, it landed on 6. And then the second roll, it landed on 3. And then the third one, it landed on 4. Okay, so state the experimental probability of tossing the cube and it's showing a 6. Okay, so state the experimental of tossing the cube and it's showing it 6. So The event that we're talking about, this is the event. The event is showing a 6. What's the chance that we're going to get a 6? So that's the event that they're talking about. So probability of showing a 6. What is the chance that she got when showing a 6? So we're going to write it like this. P bracket 6. Okay, so P is a probability that we're going to get a 6, showing a 6. Well, how many 6 in her experiment? How many times did it show up? There's 1, 2, 3, 4. 6 showed up 4 times. Okay. And how many are there altogether? How many times did she did the experiment? So that's 8. Okay. So this is how many times 6, the number 6 showed up. Okay. And then the 8 is how many trials did she do? Okay. So 4 out of 8. So based on her experiment, there's 4 out of 8 chance that it's showing a 6. 4/8. Okay. Well, what about in theory? In theory. So in theory, what should happen is that there should be the only possible outcome are 1, 2, 3, 4, 5, 6. So the only possible outcome is either showing up a 1. Where's the 1? 1, 2, 3, 4, 5, or 6. Those are the only possible outcomes. But what's it? What is supposed to be the chance of getting a 6? So probability of showing a 6. In theory, what should have happened? There's only one 6. There's only one 6 in this die. 1 out of 6. Okay, so how many 6? I'll just put in our possible outcome. And then over here, what does a 6 means? These are how many possible outcomes? Okay. So in terms of experimental probability, it should be 4 out of 8. In terms of theoretical probability, it should be 1 out of the 6. Okay. So that's the difference between those two. Let's take a look at example 5. Okay. So there are 4 red marbles. Gotta be careful in here. So now we have so many things going on. So we got 4 red marbles. Okay, I don't have any marbles, so I'll just 3 blue marbles, 2 yellow, and 1 green. Marcel chooses a marble out of the bag and then replaces it each time. He does this 5 times. Okay, so at this particular point, this explains, I gotta continue on. Then he chose the following colors. Okay, so from here, Marcel chooses a marble out of the bag and then replaces each time, and he does that 5 times. He chose the following colors and this 5 draws. So picking it up. He chose the first one was green, the second one's blue, third is yellow, green, yellow. So from here, there's an explanation of what he did. So this is an experimental probability. Okay, because looking at this, he's actually picking and choosing, going through the experiment, going through the trial. So express the experimental probability of choosing a green marble. Okay, so this is our event. This is the event. It's going to go here. That's the event or the situation that we are interested in. What's the chance that we're going to get a green marble? Okay, based on the experiment. Based on the experiment, what is the chance that we're going to get a green marble? Okay, so probability of drawing or picking a green. Okay, so I'll go here, P brackets green. What's the chance that it's going to be green? So let's take a look. How many times did he get green? 1, 2. 2 greens. So 2 greens. 1 green, 2 greens. So 2 greens out of how many trials did he do? Out of 5. So how many greens? I'm just going to go greens. That's because that's the event. And then how many trials? Okay, how many times did he try to draw a marble? Okay, so that's probability in terms of the experimental, going through the motion of picking and choosing. Now let's take a look at theoretical. Theoretical is what should have happened. Okay, what should have happened? So in theory, what happens is that what are the possible outcomes? Here are okay. Now we know that there are 4 reds, 3 blues, 2 yellow, and then 1 green. 1 green. So what is the chance that we're going to pick a green? Probability of green. Okay, well, all of these marbles are in the bag. They're all mixed together. How many greens are there? They're just basically looking at, well, how many greens are there? There's only 1 green. 1 green. Well, if there's 1 green, how many are all together in the bag? How many possible outcomes? How many marbles are there? So there's 4 reds, 3 blue, 2 yellow, and 1 green. So that's 7, 8, 9, 10. Should be 10 marbles. So there should be 1 out of the 10 chance we're going to get a green. I'm just going to do an explanation here. How many greens? Quote unquote. And then how many possible outcomes means how many marbles, or so how many green marbles and how many possible marbles. Maybe I should put here green marbles. Okay, so how many green marbles? So if you just look at how many there are, there's only 1 green. So 1 green out of how many? All of them in the bag. There's 4 plus 3 is 7 plus 2 is 9 plus 1 is 10. So 110. So what does that look like? That the probability, experimental probability, is different from theoretical probability. And we're gonna go a little bit over, but we'll try to finish this. Let me give you some time to work on this one today too. So it is important to know that for a large number of trials in an experiment, experimental probability begins to approach theoretical. So what they're saying is that the more we do trials, more number of trials, then the experimental probability begins to look like the theoretical probability. So it says here, this is like something that we've done. Bindi tosses the coin 10 times. She records her findings. Okay, so this is her tossing the coin. This is the experimental. That's experimental probability. She's going through the experiment. Okay, she records her findings. So state experimental probability that it's going to land on head. And this is the event that we're talking about. So probability that it's going to land on head. What is the chance that it's going to land on head? Well, how many heads are there? 9 heads. How many trials? 10. Okay, so number of heads in an experiment, and then number 10 is number of trials. Okay, 9 out of 10. Letter B, state the theoretical probability of landing the head. So possible outcome. So we don't care about the record. We're just looking at the possible outcome. Okay, so the possible outcomes are either head or tail. Those are the only 2 ways that when we toss a coin, it can land. So probability of head. So how many heads? There's only 1. Possible outcomes, 2 outcomes. Okay, number of heads. And then the 2 would be number of possible outcomes. Okay, So that's that. And then finally, what would happen if Bindi tosses the coin 20 times, 100 times, a million times? Well, what's going to happen as the number of trials increase, as the number of trials increase, the experimental probability gets closer to theoretical probability. Okay, there you have it. So we did finish, and so for the rest of the day today, you could continue working on. You can work on the assignment one, and I'm gonna ask you to give this one a try for sure. Um, so assignment number one on page 5 and page 6. Okay, so I'll leave that with you for now. Like I said, if you have any questions or concerns in any of these topics, or even in the previous topics, just let me know. Send me an email, and we will try to sort it out for you. Okay. Have fun learning, and I will talk to you again soon. Thanks so much. Bye for now.